guys, welcome back to the channel Engineer Study. Here we are learning the various microcontroller. And in today's lecture we are going through the basic microcontroller 8051. In last video we go through the what is microprocessor and microcontroller. So we already have an idea about the microcontroller. So now let's go through the 8051. 8051 is one of the first and most popular microcontroller. It is introduced in the year 1981. These microcontrollers were named as 80C51. Here C means CMOS technology. CMOS means complementary metal oxide semiconductor. It is an IC on a PCB. It is a battery powered memory chip that holds the initialization of data. 8051 is an 8-bit microcontroller, means it has a data bus of 8 bits. It is referred to as a system on a chip because it is a chip that holds the many components of a computer together on a single chip. Now let's see the features of 8051. 8051 has 4 KB on-chip ROM, means program memory, which is used to store the program. 128 byte on-chip RAM, means data memory which is used to store data. It has 8-bit data bus of bidirectional and 16-bit address bus which is unidirectional. In 8051 microcontroller, two 16-bit timers are available, timer 0 and timer 1. Timer 0 is divided into two 8-bit parts, TH0, TL0. Timer 1 is also divided into two parts, TH1 and TL1. .8051 has instruction cycle of 1 microsecond with 12 MHz crystal frequency. That means it has a clock frequency of 12 MHz. 8051 has 4 input-output ports of 8 bits, that are port 0, port 1, port 2, port 3. .8051 has 4 register banks, bank 0, bank 1, bank 2 and bank 3. 8051 has 5 interrupts, from that 2 external and 3 internal, that is INT0, TF0, INT1, TF1, RI, TI. 8051 has 128 user defined flags, 16 byte bit addressable RAM, 32 bit general purpose registers of 8 bits. It has 16-bit program counter and data pointer. 8051 microcontroller specifies some special function features like UART, ADC, OPAMP, etc. It has a stack pointer of 8 bit. It consists PSW of 8 bit. It also has serial data transmitter and receiver for full duplex operation. Now let's see the applications of 8051. The 8051 microcontroller application includes a large amount of machine because it is used for incorporating inside a project or to assemble a machine using. Let's see the major applications of 8051 microcontroller. First is touchscreen. The advanced degree of microcontroller integrate the touch sensing ability within their design. Transportable devices such as cell phones, media players, gaming. These are some examples of the microcontroller integrate with the touchscreens. Next is robotics. 8051 microcontroller is used in robotic applications to control the movement of robots, sensors and actuators. Microcontroller is used in various medical devices such as glucose and blood pressure measurement machines for monitoring and measuring the exact result in real-time computational environment. Can be used in automobile sector. It can be used in home automation system to control lighting, temperature and security system. 8051 can be used in industrial control, home appliances, communication systems, aeronautical and space, defense system, radio and networking equipment, and remote sensing elements. Let's move towards the main part of the microcontroller, that is the architecture of 8051. This is the conceptual architecture of 8051, which shows main devices, that is CPU, oscillator, I/O ports, serial ports, interrupt control, ROM and RAM, and timers. And this is the main architecture of 8051. After seeing it, we think it's very difficult. Yes, it's difficult, but I am telling you how can you remember this. Let's go. 8051 has 4 ports, 2 at upper side and 2 at lower side. At upper side, port 0 and port 2 are available. These are the port 0 drivers, port 2 drivers with port 0 latch and port 2 latch. Same at the bottom side. Port 1 and port 3 are available with drivers and latches. The center part of the microcontroller is the CPU, which consists ALU. It is used to perform arithmetic and logical operations. For performing any operations, ALU requires 2 inputs, temp1, temp2. For performing arithmetic operation, ALU requires the input from the accumulator, and the status of the result is shown in the PSW. This is the register B. This is the timing and control unit with instruction registers, which has the pin connections PSEN bar, ALE, EA, reset. The clock signals are provided by this oscillator to timing and control unit. It has 2 oscillation pins to generate the clock signals, that are XTL1 and XTL2. These are the special function registers, which also contain interrupt, serial ports and timer blocks. This is the stack pointer, which is used to point out in the stack memory. This is the RAM. This is the ROM. These are the program address register, buffer, PC incrementer, program counter and DPTR. And these all are connected by using bus, which are used to transmit and receive the data to 8051 PCB supply provided by the supply lines VCC and VSS. Now we are going in details of these architectures. First is the CPU, means microprocessor, which is the heart of this microcontroller unit. It consists 8-bit ALU, accumulator, register B, PSW and stack pointer. The first is the ALU, which is the arithmetic and logical unit, which is used to perform the arithmetic and logical operations on 8-bit. The arithmetic unit can perform the addition, subtraction, multiplication and division. The logic unit can perform the logical operations such as AND, OR, XOR, as well as rotate, clear and complement. The ALU also looks after the branching decisions. It operates on the 8-bit data. The result of the ALU is directly stored in the accumulator or the destination given in the instruction. The status of the result of ALU is shown in PSW. For performing operation in ALU, it requires 2 inputs and 1 input should be from accumulator. Now it can perform the operation as per the opcode, means command, and send the result directly in accumulator or the destination given in the instruction, and the status of the result is shown in PSW. The next unit is accumulator. It is an 8-bit register. It always holds the data on which the operation has to be performed and always store the result of arithmetic operations and some logical operations. Some logical functions apply exclusively to the accumulator, such as rotate, parity computation, testing for 0. Next is register B. It is an 8-bit register which works as a general purpose register. It is mainly used for multiplication and division operation with the instruction mul AB and div AB. This is the instruction part. We will see in the lecture of instruction set. Next is program status word. It is an 8-bit register used to show the status of result, cause many instructions implicitly or explicitly affect the several status of flags. This is the format of the PSW. It has 8 bits and every bit shows the sum status of the result. First is the bit 0. Bit 0 is for parity flag. It shows the number of ones in result. If the number of ones in result are odd, then the status flag is 1. If the number of ones in result are even, then the status of the flag is 0. Bit 1 is the undefined flag. Bit 2 is the overflow flag. If the result is overflow, then it will be set, otherwise it is reset. Bit 3 and bit 4 are used for bank selection. RS1 and RS0 bits are used to select register bank. If the status of the RS1 and RS0 is 00, then the register bank 0 is selected. If it is 01, then bank 1 is selected. If it is 10, then bank 2 is selected. If it is 11, then bank 3 is selected. Bit 5 is for the user defined flag. If the operation is performed by the user, then it will be set, otherwise it is reset. Bit 6 is the auxiliary carry flag. If the carry is generated on the 4th bit, then it will be set, otherwise it is reset. Last, bit 7 is the carry flag. If the final carry is generated in the operation, then this bit will be set, otherwise it is reset. Now your doubt will be clear by this example. See, if accumulator contains 98H and register B contains 88H, and we have to perform the addition of these two numbers. For this, we need to take first the binary number of these. The binary number for the 98H is 1001 1000, and the binary number for the 88H is 1000 1000. Now perform the addition of these two numbers. 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 0 is 0, 1 plus 1 is 10, so 0 is here and 1 is carry. Now again 1 plus 1 plus 0 is 10, so again 0 is here and 1 is carry. 1 plus 0 is 1, and next 0 plus 0 is 0, 1 plus 1 is again 10, so 0 is here and 1 is carry. This is the final carry, and this is the auxiliary carry, cause here the carry is generated from bit number 3 to bit number 4. See, after the first 4 bit addition, if the carry is generated, this carry is called auxiliary carry. Means when carry is generated in bit 3 to bit 4, that's called auxiliary carry. Other carries are not the auxiliary carry. Now see the status of the PSW. Here carry flag is generated, that means it is 1. Here auxiliary carry is also generated, that means it is 1. This operation is not performed by user, that means it is 0. Here we can select the bank 0, that means it is 0 0. Here result is not overflow, that means it is 0. This bit is undefined, so we can put any value at here, 0 or 1. We are taking here 0. Last is the parity flag. See the result. In result, number of 1 is 1. This is the odd number, so the parity flag will be set. Let's calculate the value. The upper 4-bit value is C1100. That means C. For the lower 4-bit is 10001. So the PSW value is C1H. Here we see how can PSW is calculated. Now the next point is data pointer. It is a 16-bit register which is used to hold the 16-bit data. Its function is to hold a 16-bit address. It may be manipulated as 16-bit data register or two independent 8-bit registers, that is DPH and DPL. It serves as a base register in indirect jumps, lookup tables, instructions and external data transfer. The next is stack pointer. The stack is a section of internal RAM used by the CPU to store information temporarily. This information could be data or an address. CPU needs this storage area since there are only limited number of registers. That means stack is a temporary memory, and the register which is used to access the stack memory is called the stack pointer. The stack pointer is an 8-bit register and it allocated in the SFR area with the address 81H, and it can point an address location between 00H to FFH. Stack pointer is used to hold the address of top of the stack. This register can hold one 8-bit address at a time, which is actually the memory location at top of the stack. The stack pointer is initialized to the value 07H when the 8051 microcontroller is reset. That means whenever the microcontroller is reset, then the stack pointer starts the address of 07H. Next is the program counter. Program counter is a 16-bit register which is used to hold the address of next instruction to be executed. When the 8051 is initialized, program counter always starts at 0000H and is incremented each time an instruction is executed. That means program counter starting address is 0000H and it can be incremented by 1 byte, 2 byte or 3 byte as per the instructions requirement. The next is timer counter unit, which is also important. 8051 has two timers of 16 bits, timer 0 and timer 1. It is divided into two 8-bit parts. Let's see. Timer 0 is divided into two parts, TH0 and TL0. Timer 1 is divided into two parts, TH1 and TL1. This unit can be used for a variety of tasks such as measuring time intervals, generating PWM signals and counting external events. When the timer counts the internal pulses, it becomes timer, just like a alarm clock. When the timer counts the external pulses, it becomes counter, just like the money counting machine. Next is the timing and control unit. This unit derives necessary timing and control signals for internal circuits and external system bus. Oscillator is used to generate the basic timing signals by using the crystal oscillator with the lines XTL1 and XTL2. Next is the instruction register. It decodes the opcode and gives the information to timing and control unit. The next is memory. To perform any operation, microcontroller requires a program to guide the microcontroller to perform the specific task. This program installed in microcontroller required some on-chip memory for the storage of the program. So, the 4 KB of ROM is available in 8051 and it can be expandable up to the 64 KB. You can see this diagram. Microcontroller also required memory for storage of data and operands for the short duration. So, 128 byte RAM is also available in 8051. The next is interrupts. Interrupts are the events that temporarily suspends the main program and pass the control to the external sources and execute their task. That means during the execution of main program, if any external event occurs, then microcontroller suspends the main program and handles the external task. This is called the interrupts. The types of interrupts are timer 0 overflow interrupt, timer 1 overflow interrupt, external hardware interrupt INT0, external hardware interrupt INT1, serial communication interrupt RITI, timer and serial interrupts are internally produced by the microcontroller, whereas the external interrupts produced by the additional interfacing devices or switches that are externally connected with the microcontroller. Next unit is input-output ports. In 8051, 4 8-bit I/O ports are available, that are port 0, port 1, port 2 and port 3. The last is bus. Bus is a group of wires which uses as a communication channel or acts as means of data transfer. The types of buses in 8051 are address bus and data bus. Address bus is of 16 bits. It is generally used for transferring the data from CPU to memory. Data bus is of 8 bits. It is generally used for transferring the data from one peripheral position to other peripherals. This is all about the architecture. Now let's move towards the pin diagram of 8051. This is the pin diagram of 8051. By seeing this is really difficult to understand. Let's simplify. This is the 40 pin IC. It is common for 8031 and 89420 also. First apply the ground supply on pin number 20 and VCC supply on pin number 40. After that, port 1 is number 1 to 8. Left pin number 9. Port 3 is available at pin number 10 to 17. Port 0 at pin number 32 to 39. And port 2 pins are starts from pin number 28 to 28. Now, pin number 9 is the reset pin. Pin number 18, 19 are the XTL2, XTL1 pins. Pin number 29 is the PSEN, 30 is the ALE and 31 is the EA bar. Let's see the explanation. Pin number 1 to 8 belongs to the port 1 of microcontroller. Port 1 is used as a domestically pulled up quasi-bidirectional input-output port. Pin number 9 is the reset pin which is used to reset the microcontroller. Pin number 10 to 17 belongs to port 3 pins used for both input-output operation. It is also used for external memory interfacing. Some of pins have alternate functions as below. RxD pin is used to receive the data. TXD pin is used to transmit the data on ports. INT0 and INT1 are the external interrupt pin. T0 is the timer 0, T1 is the timer 1. WR pin is used to write data on ports and RD pin is used to read the data from ports. Pin number 18, 19 are the XTL1 and XTL2 pins. These pins are used to connect an external crystal oscillator which provides the clock signal to the microcontroller. Pin number 20 is the ground supply pin. Pin number 21 to 28, these pins are belongs to port 2 which can be used as input-output operation. These pins also have higher order address pins. Pin number 29 is the program store enable pin is used to select the external ROM for program execution. Pin number 30 is the address latch enable pin which is used to demultiplex, that means separate address and data pins. EAR-VPP is the external access pin which is used to store the data in external memory. Pin number 32 to 39, these pins belongs to port 0 of microcontroller. These are bidirectional pins used to transmit and receive the data. These pins are multiplexed data pins with lower address pins of AD0 to AD7. Pin number 40 is the pin which is used to provide the VCC supply to the circuit. That's all about the 8051 microcontroller. If you like this video, please subscribe it, like it and share it. Thank you for watching.